Okay. Well, folks, thank you very much for coming to see a presentation about the absolute fastest and I think best airplane ever produced. We will introduce our panel in just a moment, and I want to make sure that if you all would just check your pocket and make sure your phones are not set to go off in the middle of the presentation. All right. Oh, I have to turn the switch back on, saving electrons. There we go. So it's the only operational sustained Mach 3 aircraft. There have been other airplanes that have reached Mach 3, some for a short period of time, but this one sustains Mach 3. Looks like we need a few more chairs. So we will, my wife's telling me to hold the mic up. Yeah. So I'd like to introduce our panel now, and what we will start off with Terry, and you just, and gentlemen, we'd like the audience to have a lot of participation. So if you could keep it to about 2 minutes of your SR function focused in on it, and then maybe just a little bit about maybe where you were born or something like that, and then off we go.
Terry Pappas, I was one of the pilots that flew this airplane in its last 5 years of its operational service.
Keep going. Closer to you.
Okay. Originally, I was born in Winston-Salem, North Carolina. Moved to Florida, went to the University of Florida, graduated ROTC, entered the Air Force, became an instructor pilot in the T-38. Then did a non-flying tour, went to Korea and that tour, got out of the Air Force in late 70s, 79. They asked me to come back, and I wasn't too sure I wanted to, but I did, and I'm glad I did. I ended up flying the B-52 for 4 years, and that really prepared me to apply to the Blackbird. That was a complex airplane, complex mission, very demanding, a lot of air refueling. And so when I did apply to the Blackbird, I was well prepared, and so boy, I got in because it was very challenging. The simulator was incredibly difficult, the interview process. But biggest thrill of my professional life was to be called and told that I've been selected for this program, and then to show up and fly operational missions. John Manzi was my backseater. We had a wonderful time together, wonderful career together in that airplane. But thank you.
Hi there, my name is Peter Law. I am still an engineer at 87 3/4 years old. I started back at Lockheed in 1959 working on the F-104G. I'm a thermodynamics engineer, graduated from Stanford in 1958. And I went to work at Lockheed on the F-104G, which is the German version in the environmental control system. And then Beveridge stole me. He was going to borrow me for a year. And it just happens to be that I have my 40-year skunk pin on, which meant that I was able to be there for all 40 years, and all the stuff we did in between. Ended up my last 21 years as head of the thermodynamics department at the Skunk Works, and I couldn't have asked or a better place to ever work. It's like you say, when you're in the right place at the right time, that's me. And by the way, the SR-71, when it flies up there at 85,000 feet, is going 2,200 miles an hour at Mach 3.2, 3 times the speed of the sound. The air that's taken on board to run the engine has a temperature limit, and it's usually flown in that area, 800 degrees Fahrenheit. So that's the environment that the airplane is flying in, that these guys have to live through. With the 800-degree air going into the engine, comes out of 3,400 degrees out of the back of the afterburner.
And a stretch. I'm McKendree. I was born 73 years ago tomorrow. Okay, happy birthday. So I expect a birthday cake from you guys over with for sure. Well, no, I'm not buying a bar. Okay. Anyway, I started out very young flying airplanes. My dad was an airline pilot, my mother was a stewardess. I didn't have a choice. I ended up flying airplanes. Before I got in the Air Force, I was flying Twin Beaches, C-46s, Constellations. Then I went to pilot training in the Air Force, so it worked out fairly quickly for me. Ended up being a T-37 instructor pilot my first 4 years, and then I went to USAFE flying F-111Fs out of RAF Lake Heath, and that was followed by assignment flying SR-71s from 86 to 90 when the program shut down. Retired from the Air Force after 20 years, got hired by UPS Airlines of all things, and flew 747s, 757s, 767s, and MD-11 aircraft for the next 22.416 years at UPS. And this gentleman sitting right here is one of my co-pilots, but now he is a captain on the MD-11. Fred, thank you for coming.
Hello, my name is MacKean, and unlike some of these exotic backgrounds that these people had, I was raised on a farm in Iowa, but I always looked up and every time I heard an airplane flying over the farm, and always had a thrill for aviation. And we had some good friends of the family who survived World War II flying B-17s and B-24s, so I had it in my blood. But unfortunately, the blood didn't get to my eyes. I had bad eyes, so I didn't think flying. But I later on found out I could be a navigator. So I said, well, that's another alternative. I'll go that way. So I got into the Air Force through, not ROTC, but the OTS. Went to, my first assignment was B-52s at Beale Air Force Base up by Sacramento. And I looked over at where these guys were stationed with the SR, and I said, wow, I want to do that someday. And so I went over and talked to the squadron commander, the SR squadron commander, about getting in the outfit, and I was a lieutenant. And he said, go get some time and experience, and then come back and talk to us. So I took his advice and went off and flew 111s for a few years, and then did a staff job, and then somehow was lucky enough to get selected for the program in '78. And got to fly it for about 3.5 years. And then unfortunately they said, go sit at a desk and be the ops officer for the squadron. And then a good friend of mine, we were going to open up an operation in England full time, where we used to just rotate over there. We set up a permanent operation. So he asked me to come along and be his number 2. So I went over there in '82, and then when he left, I took over as a commander of the place in '86, and got back to the States and worked with the program and the logistical background to get it going. So I was with it to the end when they closed it down, retired from the Air Force, and then worked on the reactivation program for about 3 or 4 years when we brought it back the second time as a civilian. But great airplane, loved every minute of it, thousands of stories, and most of them are true.
Good morning. My name is Jack Schaab. came to the program in May of 1975. I started out as a maintenance team member on the midshift pre-flight crew, and then worked my way to assistant crew chief of 958, which I was part of the maintenance team that participated in the 1976 speed and altitude runs that we did for the bicentennial. And then I went to Okinawa for a TDY and crew 960, and then I came back and went back again and crew 975, this is right here. And then I went to phase dock, and I spent about 2.5 years in the phase dock, where I got the Master Technician Award. I left the program in June of 1980, and then returned in March of 1983 over at Det 1, where I stayed there for about 4.5 years. And I was a maintenance supervisor on the swing shift. Did all the training and certifying, everything for the guys that were on the mid-shift crew, or on the swing shift. And I left the program in July of 1987, went to Langley Air Force Base where I retired in 1992.
Thank you, Jack. So, ladies and gentlemen, down a little bit, down a little bit. So, before we move on, I have to make a special presentation. The gentleman behind me, Pete Law, I met when I went to work at the Skunk Works in '95. Oh, by the way, my introduction is I'm Stormy Boudreaux. I flew SR-71s. Later, I went to work for the Skunk Works. When I was working there, Pete was in the thermodynamics, probably was the lead of the group by then. And everything that Lockheed has produced that most of us can look back in a history book and see, he's been involved in creating the thermal products that keeps people like me, little pink body, now big pink body, cool when we're flying at Mach 3 and the outside air temperatures coming in are extremely high. But one of the things, now most everybody in here, the reason why you're here is probably either one, you're an SR-71 enthusiast, or two, you're just an airplane nut, right? Okay. Most of you know the Reno air races. They're pretty close to here. If I was talking in Connecticut, it'd probably go over flat, but every winner of the Reno air races ever has had his design or his input to the aircraft that won ability to actually win, because his designs for getting the air in, cool the engine, maybe a little bit to blow on the pilot, and get it out of the airplane without increasing the drag on the airplane, has caused him to be the one who has his name associated someplace in an asterisk as the person who is involved in every winner, and virtually everybody at the entire place. He volunteers this. This is not something they paid him mega bucks for. He just loves the Reno air races and goes there. So a really nice hand for Pete Law. And that's this year's winner sitting up there. The picture of you and it's hard to see there, Pete, but I'll show it to you later. Okay. So the SR-71, I'm going to talk a little bit about it, but what we really like to do is get you to think about and ask questions. And the panel, not me, the panel is going to be the one who's going to answer some of these questions. So this is a 1959 design. When you think about it, the U-2 was flying over Russia, and the people at that time thought, the Russians will never be able to see the U-2. And they saw it the very first mission it flew on. And then the second and the third one, and they realized, this airplane is not going to be survivable flying over Russia. It's only a matter of time before the missile design catches up with the airplane's capability. And sure enough, a lot of people think when the Russians shot down Gary Powers in May of 1960, that's what started the SR-71. But the design was already being worked well before that. And sustained supersonic flight. I work with, on the Lockheed team for F-35s. I work with pilots, our current, everyday Navy and Air Force and Marine Corps pilots all the time. And their understanding of an airplane that goes to a limit is that you get it to the limit, and you look around, you look at that, and you go, maybe you take a selfie, and you go, I gotta go land. I'm out of gas. When the SR-71 gets up to Mach 3, you look around and you go, okay, an hour from now, I'm start looking a little closer at my gas. And it's just inconceivable to them that an airplane can cruise at Mach 3. Not just a little dash and say, hey, I get that point, now I have to slow down. This is talking about all of the challenges from heat. And if you're close enough to read, on some of the bottom you'll see the standard temperatures around the fuselage are in the 500 degrees. The windscreen gets to be 600 degrees. I'm rounding off numbers. But the average temperature is about 550. The inlet, as Pete mentioned before, is 800 degrees. And how he ever takes 800 degrees and gets it cool enough to blow 70-degree air on my body when I'm in the pressure suit, I don't understand it. I know he does it, and I got the idea, but if I had to design it, you might as well go back to the Wright Flyer. There are a number of airplanes that are in this particular family of airplanes. It started off with the A-12 that the CIA flew, then a YF-12, which is a derivative of an A-12 that they used as a perspective interceptor. And then a little later on, they decided to take the basis for the A-12 and see if we could make a better reconnaissance airplane out of it. And there's a number of different features. Most people look at a picture of an A-12 or a picture of an SR-71 and they go, well, that's the same airplane. It's all SR-71 because that's the name that's out there. But there are different airplanes. You guys are so lucky. You're so close to Palmdale. And at the Palmdale Air on, what street is it on? Is it on M?
Avenue P.
Avenue P. There is an SR-71 and an A-12 nose to nose. And you can look at them and you can see why they're so close, that they're similar. But if you look really carefully, the nose on an A-12 does not come off, so you can't put reconnaissance equipment in it. The tail is shorter, and the amount of fuel that the SR-71 carries is more than the amount of fuel that the A-12 carries. The poor one guy flying this and trying to keep the pointy end going straight when things going bad, and turned the camera on, and unfortunately it only carried a camera, the A-12, but the SR-71 carried camera and carried electronic warfare systems, electronic collection systems, more than one camera. I said camera, but it's really could carry up to about 3, I think, if the total number's right, or a radar. And so it did a lot better job in the reconnaissance role. Now this chart takes a little bit to understand. Of the A-12s, 13 were built, 5 were lost. They built M2s, which was an article that carried a drone on the back of it that was also going to be a Mach 3 drone. And they lost one of those during flight test. I think it was the 4th flight test. And unfortunately, one of the guys flying in that drowned after the 2 drone and the airplane hit together. The airplane went out of control, they bailed out of it, or were thrown out of it, and ended up in the water in the Pacific, and one of the guys drowned. Kelly Johnson said, that's enough of that mess. We'll put the M21 drone, the D-21 drone on B-52s, and the B-52s carry them and drop them from then on. There were a couple of the A-12s were modified to make YF-12s, 3 of them. And this is where numbers start to get really confusing when you start to try and calculate how many airplanes there are out there. Because one of these YF-12s gets mated later on with a engineering mock-up for a cockpit to create another two-seater when they lost one of the original two-seaters for the SR-71. So do you call that a manufactured airplane when you take 75 to 80% of the airplane's already been built for another purpose and you add a nose to it and call it a new airplane? So people get all wrapped up as to how many of these airplanes are ever built because they're kind of cheating here. They're using it twice. And SR-71s, you can see the numbers there, 2B models, and this one that I was talking about where they took a YF-12 and mated it with to give you a total of 32, but there's always an asterisk by that when you start about it. I'm not going to read all these numbers to you, and I'm not going to leave this slide up for very long, but total Mach 3 time is over 11,000 hours. 11,000 hours. Now, our closest competitor, if you want to call it a competitor, would be the XB-70. And its numbers in minutes at Mach 3 are in the 2 digits. Okay? Just to give you an idea of the difference between the two. And it was not faster than the SR-71. And as we come on down, you see a whole bunch of other things. 25,862 air refuelings. These are numbers that impress us, maybe not you guys. Okay, come on, there we go. Sorry. So, there are a bunch of world records. Some of them were set in '74 when they flew the airplane from New York to London and back from London to Los Angeles. And then in '76, the bicentennial for the United States, the SR set 3 records. Let's see. Pat Bledsoe, stand up, Pat. Pat's one of the world record holders there at the closed course. This one here. The straight course was Al George, and the altitude record was, come on, his name's going to pop out of my head now. Belt. What was it? Bob Belt, yeah. Oh, I pressed so wrong. All right. Come on, go back one. All right, those are the world records then, and it's supposed to have a slide. There we go. Now, Ed, is Ed in here? Ed Yielding over here. He's responsible for these 4 records. They essentially wanted to fly the airplane from coast to coast, and they realized that there were a couple of records that were set from city to city that they could very easily make the course go. So in the process of going from coast to coast, they touched Los Angeles to Washington, D.C., St. Louis to Cincinnati, and Kansas City to Washington, D.C. to set other world records at the same time. Ed, thank you very much. And if you guys haven't heard Ed talk, you have to listen to his presentation when he gives it. So, the agency operated several airplanes, the A-12s. They flew them out of Okinawa primarily against Vietnam, but they also did 3 overflights of North Korea looking for a ship that had been, an intelligence ship that had been taken by the North Koreans. And then when Cuba was starting to kick off during the early 60s, when the Cuban Missile Crisis happened, and we had U-2 pilots shot down over it, they had, and very few people know this, they had taken one of the A-12s out of the Area 51, repositioned it at a base in the southeast United States, covertly, and were prepared to fly it across Cuba, but things wound down and people started talking sense rather than nuclear war before that ended up happening. But they were prepared to fly over Cuba. The SR flew in all of these locations. And like it says, we didn't overfly. By that time, President Eisenhower had promised the Russians that the United States would not overfly Russia again. He didn't say anything about any other countries. And So we came very close. In this sense, it's not like close where we're going to overfly them, but just close to them. They declared a 12-mile limit, or at least we recognized a 12-mile limit, and we would go within 12 miles and 300 feet of them. And here's another area. These blue circles are the primary areas where the SR-71 flew. Once again, we had some very long missions when the first war between Israel and a lot of the other countries in the Middle East occurred, and many of the allies of the U.S. were just deathly afraid that if they put a U.S. airplane on their soil that got involved in the war, that the oil would be cut off from them. So they were reluctant. Reluctant's not the right word. They said, no, we won't support you. So they had to fly missions from the United States all the way across the Atlantic, across the Mediterranean, into this area, and then back to the United States again, which led to, I think it was total of 10, close to 14-hour missions, which is a long time to sit in one seat and not be able to get up, stretch your legs, go to the bathroom, or any of that other stuff that we consider air travel today. And this is the general layout of an SR. The light blue, you see a lot of the airplane was fuel. The rest of it was engines. If you look at the SR by getting right in front of it and looking, and you look at the size of the fuselage, you look at the size of the engines, and you go, oh my gosh, the engines are as big around as the fuselage is. And then here, today, I'm hoping that you guys will be able to just ask our group questions. And here's some of the places that we know that we'll be able to give you a correct answer, or if we can't give you a correct answer, we'll just lie to you, but you'll never know the difference. Inlets, engines, fuel, environmental, aerodynamic properties, handling qualities, air refueling missions, some gee-whiz numbers, pressure suit, intel, radar, opticals, nav, the missions. This whole thing was a very complicated dance that we had to go through. And Ben Rich was the propulsion genius. Kelly Johnson was the overall leader of it. A lot of us, with all of the years that he spent in all of the airplanes that he did, most of us adore the man, you know, as a godlike almost fellow from the, what was it? The very first twin-engine bomber that he worked on. Anyhow, he worked on that all the way through the SR-71. And I think we're about ready. Come on. Yes, now it's the letter to Kelly. Now, I am going to attempt to get it to there. Christy, if you know exactly where it is, I'll let you know. This letter was done, well, it's sort of self-explanatory. Yes, sir. I got ahead of myself. Glad that the boss was here. This is now the time, after I said, these are all the things that you can ask questions about. Now's the time you're supposed to ask questions. So I need hands. People who would like to, yes, orange shirt.
Can you talk about the challenges of air-to-air refueling with the SR-71?
The challenges of air-to-air refueling. So I think that probably goes to either Terry or Mac. I understand, Terry, you had a lot of problems with laughing at it.
Air refueling is such an important aspect of the operation of the aircraft. Basically, you took off half a tank of gas and looking for a tanker immediately, and you needed that refueling every hour or so en route to your target area. John and I flew a long mission in 1987 that was 11.2 hours with 5 air refuelings. And normally you come upon the refueling track and you get to a mile, and now you take over visually, and the RSO will get you in trail at a mile in case there's any problem with visibility. At that point, the pilot takes over visual, comes in, makes contact, and start taking on fuel. Well, this long mission had 5 long tracks. They extended the length of the tracks too. They were 500 miles long. And in the South China Sea on this mission, the weather was the worst I've ever seen for air refueling. It was dense clouds. So I couldn't see the tankers anymore. And technically I'm not supposed to go beyond that point, but this mission was too important. So I went into a half a mile, 500 feet beneath the tanker. Still couldn't see it. Went into a quarter of a mile, 250 feet beneath the tankers. And finally got a glimpse through the clouds, what I thought was an airplane. So I went on in, got on the boom, started taking on the fuel. Normally you'd have the luxury of getting off the boom and relaxing for 20 minutes and then come back and get the rest of the fuel. Well, I couldn't leave the boom. I had to stay in that 12-foot distance from the tanker the entire length of that track, and had to do it again on multiple other tracks. So I was flying in formation on the tankers for 3.5 hours out of that 11-hour mission. And anybody here who's flown formation knows how challenging that is, especially an extended period of time. So, and you had to do refueling day, night, bad weather, all over the globe. So it was a challenge.
Matt, can you top that?
I can't top that per se, but they used to give us a mini flight physical right before we would suit up to go get out of the airplane. And sometimes my blood pressure would be a little high. And they said, why don't you just sit there for a minute, think about waterfalls and butterflies and those kind of things. And my blood pressure would come down and I'm good to go. So I finally figured out why my blood pressure was high. Because during the briefing, the weather officer would brief the weather in the AR tracks. And my blood pressure would go up because can I find the tanker in this AR track? So that's why my blood pressure would go up. And just like Terry was saying, you'd get on the boom sometimes and it would like somebody took a wet blanket, threw it over the windscreen and would slowly peel off of the top of the airplane while you're on the boom. You're supposed to do a disconnect because you lost sight, but now I won't be able to find the tanker again, so you just hang on to it best that you can. And as all of the guys will say, the big thing is my backseater Randy Shellhorse, while I'm hooked up to the boom taking gas, and he tells the boomer, give me 4 pumps, because they can control the rate that the fuel is being uploaded onto the SR-71. Give me 4 tanks to start with, and he'd go 3 pumps, 2 pumps, stop transfer, 1 pump, stop transfer, and we're looking to have totally full fuel at the end of the AR track. The intent is if you go past the end of the AR track trying to get your gas, now you're not at speed and altitude before you go into the bad guys area. And if you leave early, you don't have enough fuel to get back to the next AR track. So it's very critical about when you top off the tanks and go. But the last 15,000 pounds of fuel you're putting on the SR-71, we are that close to being in a stall. We are underpowered. The tanker is going as fast as it can. And we're just about ready to fall out of the sky. And if the tanker has to make a turn to go around the thunderstorm, I'm getting a stick shaker and a stall warning horn on the boom taking fuel. That's how critical the weight was on the airplane and the speed that we were flying. So it was challenging, but like we had one of our guys, I'm not going to mention who, would say, well, you have any trouble on the tanker? And I said, well, it's like riding a bicycle. You know how to do it or you don't. Spent a lot of time on the tanker.
Thank you. That answer your question? Gene.
Stormy, what is your experience with the Japanese airplane being mounted?
Well, I think all of you guys both flew DAFIX for sure. No, DAFIX. He's asking about what was the experience using DAFIX. And did you transition? You would all DAFIX? So you were transition, so was I. Why don't you take this question and so you'll be able to relate the difference between what the question means before he answers. DAFIX stood for a digital automated inlet and flight control system that they added to the airplane in 1982 or so. And prior to that, it was analog computers, and now they went to digital computers, and there were some definite differences.
had a chance to fly both the analog and digital systems. Most of you probably read something about the inlet, the spike. It's called being started. Once you hit Mach 1.6, the spike starts moving aft to control the placement of the shock wave in the inlet. If there's a disturbance, aerodynamic disturbance of some kind, it can spit the spike full forward and you lose all that thrust instantly, which happens to be about 70% of the thrust on that side of the airplane. Give you a tremendous asymmetric thrust condition depending on the speed. And what they achieved by going to the DAX, the digital control, was a tighter opportunity to control that whole system, and you had less unstarts, which was great for us because every time you had an unstart, you lost altitude and you had to climb back up, and that meant you burned fuel. So it put us in a much tighter fuel state going into the target area and going into the tankers. So it was nice to get fewer unstarts with the digital system.
Was that the answer you were looking for?
I was looking for the answer when you take the airplane.
All right. I wasn't going to go there. I'm the moderator, not the storyteller, but I'll tell you this short story. So I'm flying a DAPX airplane, and it was a Cuban mission sortie which takes off really early in the morning because those of you who are photography buffs as well, you want the sun angle to be right, so you have to take off in California very early in the morning to be over Cuba at the right time of the day for the light. And so I've refueled, I've climbed up, I'm heading, I've made a big turn so that I've basically got Dallas to New Orleans on the nose. The sun is just starting to come up, so I get this little red and orange glimmer across the horizon that says, okay, I can now tell where the horizon is. I accelerate out to max Mach, my backseater is testing some other things, and as I go, okay, airplane's flying along really nice, and I pull the throttle back to decelerate, and the autopilot is running the airplane, and the autopilot's trim mechanism is a little slower than the way the pilot would turn it, and all of a sudden the airplane literally pitches up. Now, when I say pitch up, we used to make pitch movements in the SR-71 that were in tenths of degrees, just infinitesimal things. And so when this pitched up to 10 degrees, it was like the entire airplane had reared up like a horse on its back legs. And I grabbed the stick and pushed forward. And I had the nose up before and pushed forward on it, and it's kind of a heavy airplane. Push it down and it goes down. And this time I pushed forward and the whole airplane just flopped. And there was no resistance whatsoever. Boom! So the nose is down and I go, ah! And I pull back, and so now it's going up, and it's going up higher than 10 degrees this time. And my mind is saying, okay, this is not a pilot-induced oscillation, because someone else did it. They were going to blame me. But no, I got to get out of this. So when I went forward again, I realized I have to break this habit, otherwise it's just going to get bigger and bigger and bigger. And it's like you see cars go like this on the side of the road, next thing you know, they're hitting the side. So as the nose went down, instead of waiting for it to come back up, just as soon as I started, the tiniest little bit of nose up, I went full nose down and started running the trim full forward. And the nose came up and it started quivered with the pitot tube right around the horizon. And I went, oh, I got this under control. But no, because here I am flying with a stick, and the reset switches, by now I've determined that it's triple computer failure. 1, 2, 3, all 3 computers that control the airplane have failed. And they're on this side of the stick, my hand's here. The big old gloves that you wear won't go behind the stick to get it. Not so good flying left hand. This is the hand I fly with, but I gotta use this hand to go there. So I grab it, the airplane's pitching around, and I finally get it. As soon as I got one of the computers on, the airplane went, just like a rock. Nah, it's flying again like I'm used to. And got them all on, we discussed it, and I said, the option was, because nobody had ever had this happen, there was no emergency procedure for triple computer failure at the time, was, okay, clean it all up and go again. And my feeling was, I'm so lucky that the good Lord helped keep that nose down, that I don't think that if it ever happened again, I could do it again. So I said, no, we're going home. And before you ask, we're going home subsonic. because we always had an alternate of going home to super or something. So for the hour and a half it took me to get where I was, which was just to the east side of Denver, looking towards Dallas, and to get back was another 2 hours to drive back subsonic, the distance I'd gone. So that's the last story I'm telling here. I'm the moderator. Questions? Because you won't know what kind of answer you're going to get.
Were there ever any anti-aircraft missiles fired at the SR that came close?
You want to take were there any anti-aircraft surface-to-air missiles fired at the SR that came close? And the persons who are more in line with looking at all the defensive gear is the RSOs. And so, Barry, if you would be so kind as to take that question.
There were, I'm not sure the numbers, but it was in hundreds that were shot at the aircraft when they were flying over Vietnam, Hanoi area. None of them ever hit the airplane, but there were, I think, again, 400 or 500 SAMs that were surface-to-air SA-2s that were fired at the aircraft then. And I don't know, Edie, are you in here? Ed McKendree? He was the last one that I know that they were flying. He just pilot were flying across the DMZ in Korea. And all of a sudden they got a launch, and that one was for real, because quite frequently we would get the indications of a launch, and it was quite honestly a test on their part to see if they could control all this stuff. But this one was for real, and they saw it, and our corrective action is just to make a slight maneuver, because the end game for a missile to try and catch us, it's a bullet. We are a flying bullet, so trying to hit that thing is just impossible. So if you make any alter on your track, the missile can't correct enough to compensate for it. So they did actually get a shot. I think I don't know if they saw it explode, but it did go off. And I'm not sure there was any fragments in the airplane, but it was close enough to get their attention, certainly. But to answer your basic question, yeah, there were a lot of SAMs early on that got fired at them.
Anybody else want to add anything to that? Pete?
Okay, you have to understand something. This airplane is traveling 3,000 feet each second, 2,200 miles per hour. And the sensing equipment in the SR-71 not only can figure out where the missile sites are because they're being scanned by the radars, but they have a warning system that indicates that there was an actual launch. Not that they were just being painted, but they were actual launch. And the SR-71 backseater knows that's happened, and all they have to do is move a little bit, and when they're moving 2,200 miles an hour, 3,000 feet per second, you can get so far away from the path that they're on. Their surfaces in their missiles can't, at that low density, can't turn the missile to go over to them. But I just wanted you to understand that the airplane's flying at 80 to 85,000 feet, so that missile has to go up at the airplane as it's moving that fast. So that's why they never were shot down.
Thank you. And just for the audience, these numbers, 3,000 feet per second, means nothing to you. So you get out on one of the freeways that we have here in California, and you look at miles to go, and if it's a clear road, sometimes you can see it says this is an exit 1 mile away, and you can see the overpass where that is. And I do this with school children, and just have them say 1001, 1002, and you're crossing that overpass from when you started saying what you just said. It's mind-boggling that when your mom or your dad is speeding faster than the speed limit, And it still takes you close to a minute to get there in the car, but it's only 1001, 1002, and it keeps going on for 3,600 of those seconds for the hour. Next question, somebody else? Yes, ma'am.
I was wondering what the greatest challenge was in developing the A12.
Pete, you're the closest that we have to a developer of the A12. And I'm not going to go there. Pete, how did you answer that one?
Yes, I started working at the Skunk Works. Ben Rich stole me from the white world on July 17th of 1961. The airplane hadn't flown yet, but it was out in the hangar. It was down at the Burbank Airport. We had our own little building, Building 82 it was, and the front fuselage mock-up was there. They were actually building the fuselage and they got back into the airplane there. And all of the challenges that we had, we figured out exactly how to use the titanium, which type of titanium to use, because the temperatures were going to be 500 to a few thousand degrees. And there were a lot of difficult things that we had to do to get the airplane. The fuel, for instance, the SR holds, the SR-71 weighs 60,000 pounds dry. It carries 80,000 pounds of fuel. 12,000 gallons of fuel in that airplane. And they took off, used to take off with a full load, but they found out they could have some problems on wet runways, so they don't take off full, they take off and they run flat. But the challenges were obviously thermal because of the fact that we had 3,400 degree exhaust gas temperatures going out of the back end of that engine. And we had 800 degree air coming in, and we had all the surfaces and actuators and hydraulics and the air conditioning systems. All of those were special challenges that we all had to do. And being in the thermodynamics department, the structures guys wanted to know how hot things were going to get so they could pick the right materials. The flight control guys wanted to make sure that I cooled their equipment because they had this hot 800 degree air coming on board. How are you going to be able to get me 50 or 60 degree air to my equipment? So that was a challenge. Every different group, the propulsion group had to worry about the inlet and how the air was going to get to the engine without unstarting the engine so the pressure would stay full at the engines. Every one of those single problems was addressed by the aerodynamics guys, the propulsion guys, the thermal guys, the structure guys, the stress guys, the flight controls guys. So we had an awful lot of different things that we had to address. And everybody had their place and everybody trusted each other.
So back in the late 50s, if you look at what the materials that were in existence, there was not a hydraulic fluid in the world that could sustain these temperatures. The oil that would normally be used in the engines couldn't be used, the ones that they had. They had to then vent a lot of things. And I'm only listing 2 out of the 12 or so when I give a presentation. I don't have that chart memorized, but there's a whole bunch of things. For instance, just the engine to be able to stay in continuous afterburner. You guys go, oh, what difference does that make? Well, it heats up and it melts things. And they had to develop using special kinds of alloys that wouldn't melt at the 3,400 degree temperatures that he's talking about. That metal didn't exist, so they had to create it. And lots of other things they had to just invent. One of the things that I think was a side benefit of the SR-71 you might be using today in your car is Mobile One, a derivative of it. Okay. Yes, sir.
I have a question on maneuverability on the SRs. Just how maneuverable were they?
Sir? How about the maneuverability?
Yeah, just how maneuverable were they?
Okay, Mac? How maneuverable was an SR-71?
Not a whole lot. Airplane wasn't designed for aerobatics or anything like that. And it was G-limited by how much fuel you had on the airplane and which tanks had the fuel in the airplane. Probably the most we ever maneuvered the airplane would just be in a closed pattern back at Beale after be over Kadena or Millenhall after a mission. You would come back and you're light on fuel, and you might fly a couple overhead patterns and turn around and land. But compared to a T-38 or F-4s, I flew F-111s. No, it is not a maneuverable airplane. It is very G-limited aircraft. Except, like you said, it's all fuel tanks.
Right.
And when they're empty, they don't like that.
Thank you very much.
It's also speed limited. You hear that answer and you go, that's a joke, right? It was limited to 500 knots. You couldn't go faster than 500 knots of force against the airplane. But up at high altitude, you weren't at 500 knots. You were at high Mach numbers, but it didn't equate to indicated airspeed. That was the strangest thing, to find out that the 106 next to me while we're in formation could outrun me on the deck, much to my utter dismay, because I had to stop when I hit 500 knots. Questions? I had one over here, yeah.
Okay, taking into account speed, temperature, and all that, does that alter the shape of the frame of the plane at any point? And then
Thermal.
I'm trying to get to maintenance. So
Okay.
does that give Jack any work when you landed?
Okay, that is a great maintenance question.
The airplane actually, the 715, if you go out there and look at the joint, it extends, I believe it's about 6 inches in flight. The engine itself, about 2 inches in circumference, about 4 to 6 inches in length. The difference areas that were at different heat. So at one time they only painted the airplane black on areas that needed for the heat. Later on they painted them all. But I mean the differences would be on the back you get up temperatures up around 1200 degrees. We used to heat hydraulic fluid up to 600 degrees when we do out checks on the big hot gate. You can see the smoke coming off the hydraulic. And we had to wear fire suits and all that. But that's about how long, how much you do, 6 to 8 inches somewhere in there. Can I answer that?
Yes, please, go right ahead.
Maybe we had one of our pilots, and they were saying the airplane will, get in the lane a couple of inches as it heats up. So he's wondering if he did. So he was going to take a ruler with him. Then he realized, well, if the airplane grows and if I grow, the ruler's going to grow.
They did do a test in the engine compartment one time when they were having trouble with an accessory gearbox, and they were having issues, and they wanted to see what was moving, so they put a stylus that was fixed to one part of the aircraft and touched the engine, and you could see the difference that had happened. And if I remember right, that was a 6-inch scratch that occurred in there where it moved, and they ended up having to put, instead of a straight shaft, they articulated it. They put an elbow in it so that the thing had room to be able to accept the growth as the elbow went like this to like that, back again. Pete, you probably, please, don't take the whole hour.
Yeah, the airplane grows and the engine grows. And the titanium has a certain thermal expansion as a function of temperature. And I've done several calculations that it was between 4 and 6 inches that the airplane extended from tip to toe. And it depended upon the temperature and altitude. You know, it doesn't stay constant temperature. Altitude is continuously varying. You're flying 3,000 feet in a second, and not too many seconds you're 5 or 10 miles away, and the air temperature is different. When the air temperature goes down, the total temperature and the skin temperatures go down, and when outside ambient temperature goes up, all the temperatures go up, and it can stretch out a little bit longer. But it definitely, the titanium does make the airplane grow.
And if I remember right, Pete was the one that told Kelly, if we paint the airplane black, was 35 degrees?
Yes, that's absolutely correct. 35-degree lower skin temperature, which means it doesn't heat the fuel up as fast when you're buzzing along with all those tanks full of fuel.
Yeah, and that was a significant thing. You might think 35 degrees, but 35 degrees was a whole lot. Yes, and I have another question. Yes, sir.
So you were talking about refueling?
Yes.
And being right on the stall. So how fast are you going when you're right on the stall?
We're on 300 knots.
How fast would the tanker go?
310. No, it was less than Mach 9 because we accelerated to Mach 9. I'm sorry, I mentioned the question. He asked, was it Mach 9 there? It was at 25,000 feet, 310 knots or so. Yeah. Any other questions? Yes, back over here, now.
With all that fuel on board, with the handling characteristics of the CG, was there a huge difference in takeoff versus landing?
Sure. Handling qualities difference when you were empty from a CG standpoint to when you were full, or a heavier weight airplane. We all can answer it, but it's not my job to answer.
Full on the airplane, we got light.
As was pointed out earlier, the airplane is a long series of fuel tanks, and it's very structurally limited. You may be familiar with any airplane doing a 60-degree bank 2G turn. We were limited to 1.5 Gs at altitude and speed. So we're doing a 35-degree bank turn, and our high banks were 38 degrees. So that's because of the G limitation. You could bend or break the airplane if you really pulled on it. Now, when you get it down to subsonic and mid-range fuel, actually lower range fuel, in the right tanks, you could pull up at 3.3 Gs, I believe, and doing an air show or doing if you're literally, we did some air shows at certain times, events. So it was very delicate to be careful you didn't break the air.
And they had pumps in the tanks, ma'am, so that you could move the fuel around to keep the CG where it was needed. But so you weren't just, fuel wasn't coming out of willy-nilly, whichever tank it wanted. We controlled exactly which tank, and therefore the balance of the airplane. Like similar to that, except we're going fore and aft instead of left and right. Any other questions? Yes, ma'am.
First of all, I'd like to just thank you for your service and thank you for being there. I would just like to know, what were the physical demands that were placed on you for flying this plane before and after a flight? How did you prepare for something like that, or did you?
Barry?
What's the question?
Oh, okay. The lady was asking, excuse me, I heard her perfectly. I don't know what were the physical demands on the crew to fly? And did flying fast like that do anything different to you compared to sitting where you're sitting right now?
A lot of the guys were very athletic, I'll have to say. I wasn't one of those guys, but I did do some sports and tennis and everything. But most of the guys, again, as part of the in-processing or the interview process, they gave you an extensive physical, so they knew pretty much what condition you were and whether you were an acceptable candidate. They did all sorts of wires on your brain, the whole body. So it was a mini astronaut physical, if you will, that we got. It was a week-long interview process, so a lot of the stuff was checked out beforehand. They pretty well knew what we could do, and so, but one of their things that they had set up, I think from the get-go, was that they would give you a high-protein, low-residue breakfast before flight. We would go in an hour before we were going to take off, and they would prepare us some eggs and a steak or something like that, just to get the right things on. You wanted to get your body flushed out as much as you could before you suited up. You went in and got in the suit and then sat in the airplane for a while, but it was, the only real thing you talk about after flight, the only time I ever really noticed anything was if I had a night flight and you come back and you shortly thereafter go to bed. Well, you had so much oxygen on board that we would the bends that people get, we would pre-breathe like the U-2 pilots had to lay there for half hour to an hour, I guess it was, to denitrogenate their body to get them ready for flight. Well, when you come back after having all that oxygen on board and you have to ease out, well, in the daytime you're doing things and it's slowly creeping out of your body, you don't even realize it. But when you got home at night and went to sleep, I remember the first time I did it, man, I woke up with a piercing ear. It was just driving me crazy, couldn't get it out. So that was probably one of the only after-flight issues for us.
Good. And it's just like putting on a pair of boots. If you've never worn boots before you put them on, you go, how can I walk around in these? And then after you've walked in them for a day, it may be tiresome, but they're part of your body. Same thing with moving them around inside the pressure suit. You get used to the resistance, and pretty soon it's just your uniform to go to work in. And then another question, we're getting close to the end of the time.
Yeah. How many emergency landings?
How many emergency landings? I'm not sure that there's a count on that. How many emergency landings can we have? I mean, I never have.
I have no idea what the total is, but I know how many that I made. So one in the B model, one back to Vila in the A model, once to Bodo, Norway, once to Navy New Orleans, once into Elmendorf. I think there's another one in there somewhere, but I can't remember. So every once in a while, she would bite you. And I had one back in the Cadena that was quite scary. And long story short, we got to a point coming back from the Spratly Islands where Vietnam and China were having a little war. And you've probably read about how the Chinese have built an airstrip on this little coral reef out there. That was back 89, I guess. But coming back from that, we had a fuel control malfunction on one of the engines at exactly the wrong time in the wrong spot. And if we followed the checklist, we would have come down, as Stormy was talking about, subsonic, cruise subsonic, to try to get back to Okinawa. But we had trapped fuel in the wing tanks because it was a brand new airplane out of PDM, and some of that caulking had come out from the fuel tanks and clogged the transfer pumps. But we didn't have enough gas to get back to Okinawa subsonic. So I reconfigured the left inlet. I still had the left engine in idle to control the EGT. The right one I had in afterburner. Reconfigured the aft bypass to where I could get the ramjet on the left side to work. And I let her sink down to where she wanted to go, which was 50,000 feet at Mach 2. SST Concorde cruise altitude. So we're coming back basically on one motor and 2 ramjets, and got back to Okinawa, but it was a close fit.
Jerry?
To add something about the physiological aspect. I tell people that flying a fighter jet's kind of like an Indy 500 car, and an SR is like a land speed record run in the salt flats. Your adrenaline is pumping the whole time. You're hanging on this thing. And you're tired after a 3.5-hour flight. Well, after an extended long flight, like John and I had, I also had some physiological challenges on that flight. Not just their air refueling difficulties, but the exposure to the faceplate heat and 100% oxygen made my eyes frost over, and the cockpit became a blur to me at high altitude speed. I wasn't sure what I was going to do about it. I was kind of trying not to panic. I nearly was ready to pull it out of burner and start down to get to a safe altitude. I don't know what made me do it, but I started squinting as hard as I could, and I squeezed a tear out of each tear duct, and that lubricated my eyes. I was delighted I could still see again, but I didn't know how long that condition would last. I still had another air refueling and night landing. I also wasn't able to urinate the last 7 hours of the mission. So I was literally shaking by the time I got the airplane on the ground. And you typically, when you finish a mission, you take off your helmet, you off your gloves, you hand them to the guys, and then you stand up and get out of the airplane. I couldn't stand up. They had to lift me out of the airplane. It took me 3 days to recover from that.
Yeah, oh, how you doing, Ed?
Terry, was it you and John Nancy that delivered this airplane to the museum? Yes. And do you have any special memories about that delivery?
Did everybody hear that? Terry was the pilot that delivered this airplane here. And the question is, any special memories about that delivery?
Yes, it's also the same airplane that John and I did that long mission in. So it's special to us. Of course, that was the last SR flight we ever made together, too. So, kind of a sad day for us.
Yes, sir.
Yeah, I have a question. When a book just got released recently on the SR, and it has, they made commemorative patches for the deliveries to the museums, special commemorative patches with the names of the crew that delivered them.
Ed, was that when you delivered, did they make commemorative patches for when you delivered the SR to the museum?
Yeah, I've seen some various patches made by the Boy Scouts, but I haven't seen any special.
Yeah.
My question was, it has like 4 or 5 of the pictures of them in this book. It has the March delivery, but it doesn't have your guys' names on it. It has 2 other.
Oh, they're talking about deliveries of the airplane when it was retired to the various bases, and somebody made up some various patches to commemorate the delivery to, but he's saying he didn't see one in March. Yes, sir, Mike?
Those were not official patches. Somebody made those, started selling them.
Yep.
Some of them they got wrong.
Yeah.
My kids flight out of Pompeo
because
came out of Beale.
At the 2017
Save your money.
event here, I sat next to Rod Dyke
Yeah.
at dinner, and I asked him who delivered it, and he said it was you. So when I saw the patch, I was like, that doesn't make any sense, because obviously.
Yes.
Yeah, Dyke told me.
Yeah, this is probably for the pilots or the engineers. Can you talk about the ramjet feature of the J-58 big tubes that go around the engine and what occurs and how that happens?
Okay. Huh? Yeah, we need Audie here. There is a Pratt & Whitney specialist, but he's not here. It's very, I hate to take it away from you, it's very easy to say the airplane goes into a ramjet mode because people understand that. That's technically not what happens. But the answer to your question is about 6 pages of close, tight-knit literature that is in a very difficult for me to understand, and I'm close to it. So, yes, they were able to take the airplane. Some of that, what you're looking at, those bleed bypasses are taking air off the 4th stage and dumping it back into the afterburner to relieve the overall pressure in the combustion chamber. It's really not acting like a turbojet, I mean a ramjet, although in order to get people to press the I believe button, they say that because it's just simpler than trying to get into the lung, and by the time I'm finished, your eyes would be glassed over, and it's just not worth going there, particularly in this environment.
Is that a valve that opens up to allow a switch? Or is it a pressure?
Jack.
All right, Jack, please go. Thank you.
Basically, as you're flying along, you're about 1.6, the spike starts to move out. What you know is you get up to where you got supersonic air coming in, and the airplane has to change that from supersonic to subsonic, and that's where you get to your shock trap. And as the faster you go, the spike starts moving back, the doors close, you get more air in there. At that point, when it gets to that shock trap, the spike is what traps it. When you get that shock trap, on this side is supersonic, on that is subsonic. The temperature on the outside by the spike tip is around about -45. At the inlet, it's 800. Okay, so now the air gets in there, and what the engine doesn't use are bypasses. Nothing bypasses, of course, going to ambient air. It all goes down either through the nacelle and uses flush fuzzing. But this airplane uses 88% of all the energy that it takes in is only about 12% is lost to heat or other factors. The tubes that are on the engine, they take the air off the combustion and go back and put it back in the afterburner, so you got more power back there. What happens is you got a convergent divergent nozzle on the back, and then out the back you got the turkey feathers, and they operate by pressure. And you got 3.2 air coming out the back.
Okay, Pete, did you have something you'd like to add to that?
Yeah, I just wanted to say that the question, to answer your question, takes a very lot of explanation of supersonic, subsonic flow. And I know very well a lot of that information, but I can tell you that Arnie Gunderson, who has the patent on that, when the Pratt & Whitney was building the engine and testing the engine, they found out that they couldn't get all the air through the engine to get the right thrust. So the afterburner section of the engine is effectively at a pressure near the fourth stage bleed of the compressor. It's compressing the air that goes into the burner cans, which then runs the turbine, which then goes out the back end to give you thrust. He found that if you took some of the fourth stage air and bypassed it and put it directly into the afterburner, that it was much more efficient, and in the turbine, the compressor could handle the rest of the flow. So his invention was called the bleed bypass, and it's the only engine in that era that was actually able to do that.
Any other questions? Yes. Yes, sir.
So there was a recording that made its rounds on social media about an SR-71 pilot. It was on with air traffic control, and it was like a
No.
aircraft.
The speed story?
Yeah, the speed story.
Yeah.
Do you gentlemen have a story about maybe a time or two you had to humble a fighter pilot?
Not on the same frequency. The question is, the speed story that's out there that makes good press, but it's not exactly accurate. You wanted to take care of that. And were you able to humble that fighter pilot?
You're talking about the I'm at altitude, the F-18, and the BS. We're not even on the same frequency at speed and altitude. Okay? We're on, if you're even on anything, you're UHF. And we're above 60,000 feet. We ain't talking to anybody stateside. You're above controlled airspace. We would give, if you're flying a training sortie, you don't have time to talk to anybody. You're busy keeping the pointy end straight, et cetera, et cetera. And when you come back down to Beale or going into Palmdale, for instance, we would give LA Center we would start our descent from 78, 80,000 feet, whatever. We would start our descent, and we would give LA Center a 5-minute heads up. We're coming into your airspace from above. Okay? And they would say, oh, we want you to level off at 45,000 feet. No, we are on re-entry. We are re-entering the atmosphere.
The phrase was unable.
No such thing as leveling off.
I'll talk to you later about that. If you come see me about your question, I'd like to amplify that more. Yes, sir.
With all of the heat and the expansion and everything, did any parts of the plane melt? And what was the maintenance like after landing from a mission? Did a lot of parts need to be replaced?
Well, Pete, you can answer the melting problem, and then we'll have Jack answer the maintenance issues.
Okay, we had a few melting problems. The only melting problem we had, I think it happened twice, there was an engine compressor after the turbines in the engine put a hole through the engine. And the hole through the engine then burned a hole through the side of the thing that comes up and down in the airplane. Now, it just so happens that they were able, after they landed the airplane, to take that part of the engine, and the airplane came back. I mean, they just kept flying, and probably slowed down and came in. We had the pieces that were still on that airplane, and they did temperature Rockwell hardness tests on all the different parts and pieces to see how everything came out. And the gentleman who did this, his name was John Altizer, and he kept a lot of those pieces of the titanium that were on the hinges of the part where they were doing all those temperature tests. And when he retired, he gave me one of those pieces, and it's my prized possession. When I give it to people, it's a big hinge. I mean, if you saw the hinges, the whole outer wing tips up so they can get the engine out. If you took that as a piece of steel, you say, oh my God, that's heavy, and give it to them, they say, how come it's so light? Well, it was like half the weight of the steel, the titanium, and it could take up to, depending upon the titanium we use, it could take over 1,000 degrees without even thinking about melting, before it even reached the point where it was changing its strength. Because the titanium we used in that airplane were different levels of other minerals in them to make them take higher temperatures. But that was the only, did you remember anything else that you guys about the 2 times that the engine burned through?
Yeah, one was landing at DC, and there was a different one that, it was an air show at Washington DC that the burner blew out the side, fortunately, not into the fuel cell. But I'd like to have Jack answer, how many maintenance hours and how many people did you sick on the airplane after a flight in order to be able to get it ready to fly it again?
We had a crew of 6. And at the end of it, when it would come back, we would, of course, have to take all the engine panels off. And the main thing is when it came back, is first thing to do was put the brake fluids on it because the brakes would be smoking. And I never saw a tire go off. I understand it did, but I've never seen it go off. But anyway, sometimes you have smoke coming off the struts. And things you have to be careful for a little while before you touch anything. But to turn the airplane to the BPO and put all the hands back on and servicing and everything, about 4 hours to take the crew. I don't remember how many BPO items, like 100 BPO items. That's quite good, but that's about 4 or 5 hours.
Yeah, that's shocking with all of the little screws and all of the other.
Yeah, once in a while we'd find cracks, but that was more or less with the heat expansionists in the earlier days with the analog computers. You would sometimes find cracks. You'd see it right in the inlet.
I'd like to see if I get someone else. Yes, ma'am.
Quick question. What year is the SR-71 come here to the museum?
February 1990.
1990, okay. Thank you.
Anybody else with a question? Way in the back, sir?
I had a question about the navigation. How much more would the difficulties increase when you did prolonged Mach speeds?
Okay, I heard part of the navigation. How much more difficulty was it?
And prolonged Mach speed.
Prolonged Mach speed. I'm thinking that. Was there any difference in the navigation system because you were at prolonged Mach speed?
It got better. Excuse me, the amazing capability of that machine, when you consider it was designed in the early 60s, the navigation system, as soon as you pulled out of the hangar, you'd switch it to nav, and what it would do is track stars, celestial stars, and start tightening. They had run the INS basically for an hour or so, getting it all up nice and tight, so when it pulled out, as soon as you got out there, within about 10 seconds, it locked onto a star and then started doing it. They guaranteed it to 300 feet, and the longer you went, the better it was, quite honestly. I have almost 500 hours in the airplane. I never once updated it. It was so good, so reliable, and the beauty of it is, today, everything is GPS and
Why didn't you use the GPS system, Barry?
It wasn't reliable. They detuned the GPS originally. But actually, the beauty of it is, if the world turns to crap and they start shooting all these balls out of the air, a lot of these systems aren't going to be able to function. We were totally independent of everything out there. We had both visual, we had radar, and most of all, we had the stars that the good Lord hasn't moved in a long years, and the system was just phenomenal. It really was.
Yes, sir.
The navigation system on this airplane was so advanced that that's the primary system of the BG model.
That's true.
Same system.
For those that didn't hear that, Don was mentioning that the nav system that was used on the SR-71 was just moved over and plunked into the B-2, and that's what it uses. And I think the latest aircraft that they're building, the B-21, uses a similar system because we don't count on the GPS satellites being there, and you're not going to be able to use, if something were to happen, you won't be able to use your Waze or Google Maps because it won't work. Yeah. Yes, sir.
Can I hear about the equipment used to start the engines?
Oh, that's fun. Jack, take it away. The equipment used to start the engines. the SR-71, like many airplanes, does not carry a self-starter in it like your car does. It uses an external starter.
Yes, they call them the Buicks. 350 Buick engine in tandem.
A little closer to you.
It was on a right gearbox and a probe would go up into the starter. And you had a little tap on it to give you a green light when you were engaged. And then when you're ready to start, tap the crew chief or the guy on the thing, he started bringing it in. It's like running a hot rod. I got to be careful that they need to tap on the show. Okay, that's enough before you blow it up. But they really have a really neat sound to it. We had a Buick on the other side. Later on, they came up with the air start system. That wheel, they didn't have the milk now, but the wheel they had was like 800,000 pounds of compressed air that ran through a turbine.
Yeah, if you're a person who really is into cars, what in my day we used to call gearheads, it's just phenomenal. Take a look at the starter unit, 2 big V8 engines that you use to start this airplane. It was fantastic.
Later on,
the sound of it is just something that gives me goosebumps.
Later on, they came up with the 454s, and so they didn't quite sound the same anymore. But it was a very, and the carts were heavy, so it took 2 guys basically to line it up. You had to keep your hands up like this so you get that probe down, because if you didn't have it lined up right, it wouldn't engage.
All right, so thank you very much. We have a special video that we'd like to show you. It's about 5 minutes long. It's really got a lot of interesting things in there, and I get taking this video and dissecting it apart and telling you, oh, this one little line here means this would be an interesting write-up to go along with it, but we don't have that yet, but that's one of my plans to do. So if you could launch that, audience, you've been great. Thank you very much for being here. But don't miss this. It's called The Letter to Kelly. Turn it up, please. Up.
Or RSO.
Up.
I wasn't a member of your design team at the Lockheed Skunk Works or on the assembly line at Bill Blackbird. Nor was I a member of the Air Force at Beale, building Mall or Cadena, who kept the Blackbirds flying. I'm not even an airplane buff in the classic sense. I'm just a person that had the privilege of being around your SR-71 Blackbird, and it was an experience I will remember intensely for the rest of my life. There's just something about your Blackbird, Kelly, that words don't adequately describe. Anyone who has been near a Blackbird and felt its presence knows what I'm talking about. It's a feeling in your gut, and instantly you want to be part of it. Part of what I call the Blackbird family. Today, Kelly, you are being honored for your design work on the SR-71, and justly so. To me, the SR-71 is not only your greatest aircraft design, it is perhaps the greatest aircraft ever built. I've heard it said that you considered the Blackbird the most fascinating challenge in your career. No wonder. It was a design that was so advanced that everything that touched it had to be new. New manufacturing processes, new tools, new materials, a whole new approach. You built an operational stealth aircraft a decade before most of the world had even heard the term. It was a design so far ahead of its time that it retired before time could catch up with it. In times of crisis, the Blackbird provided 6 presidents with a unique and critical view of the world. The Blackbird served this country for just over a quarter of a century. In that entire time, it stood in a class of one. To me, the Blackbird is much more than a technical marvel. It's an airplane that gets inside you, an aircraft that causes the adrenaline to flow just by looking at it. Kelly, your Blackbird is the stuff dreams are made of. It's the model plane sitting in a young child's room, proof that everything is possible, that the sky isn't the limit. And it's the poster hanging on the office wall of a middle-aged engineer, testimony that yes, even in the real world, miracles do occur. The SR-71 embodies all that excites people about aerospace. Its crew seems part pilot, part astronaut. The Blackbird itself appears part airplane, part spacecraft. The typical Blackbird fan is a cross-section of America, It's your grandfather, your niece, your son. It's the wide-eyed young kid that buys an aircraft book at the National Air and Space Museum. It's the family that traveled hundreds of miles to an air show just to see a blackbird in person. It's the people on the Air Force Base that stopped what they were doing to watch an SR take off. Everyone, every time, no matter how many times they'd seen it before. And it's the pilot who last flew the Blackbird 20 years ago, who has the look in his eye that says, I flew the best aircraft ever made. The look that can barely contain the desire to get in an SR just one more time and light the burners. When Blackbird 972 made its final record-setting flight to Dulles Airport, I watched the television with mixed emotions. This was the Blackbird's final flight. An aircraft that was the very definition of speed and power would fly no more. But my sadness was tempered by the knowledge that this plane would now truly belong to the nation, coming to rest in the Smithsonian National Air and Space Museum. Now millions would be able to do what I have done. Be near a Blackbird, be part of the family. Kelly, in the years to come, whenever I want to experience your airplane's majesty, I will remember the time I spent with your Blackbird. The smell of JP7 fuel, the feel of it on the soles of my shoes, the sound of an air starter wind up, the TED ignite, and I'll put on the film that we shot during those incredible weeks in 1987. I'll watch it, feel it, be part of it again. Because in movies, Kelly, like in our memories, your Blackbird will fly forever. Congratulations, Kelly, and thank you. Devin Honker, Assistant Cameraman, Blackbird, the movie.
Ladies and gentlemen, thank you very much. I really thank the museum, and you thank the museum and continue to thank the museum by being patrons here and keep it alive. So many of the museums are folding these days because they're not getting enough patrons coming in. So you've come in, you've done your part, spread the word. This is one of the best museums in the West United States. So come and visit it more often. Thank you very much. We'll be available for questions.